Okay, today we're going over 6.4, solving polynomial equations. So the first thing we're going to look at is solving them by graphing. Okay, so if we have two polynomials equal to each other, then what you're trying to do is you're trying to see where they intersect. So you're finding their points of intersection. Okay, so what you can do is you can plug this into your graphing calculator. If you don't have a graphing calculator, you can actually use the Desmos app on your phone. You can get the Desmos app, and that's just spelled Desmos, and it's under Chrome, Google Chrome, or you can use your graphing calculator. We'll also find ways to solve this algebraically. So all you're going to do here, I got to this by just typing in the desmos.com/calculator, or you can just Google Desmos calculator. Okay, so we're going to type in that first one here. So we have y is equal to x. I'm just going to use the caret, which is just a shift number 6, cubed. And as it goes, it's pretty neat that it graphs it for us. So this is what x cubed looks like. Okay, and then we'll continue on. So plus 3x caret squared, and then use your arrow to get out of the exponent. That's my first graph, so that's what that one will look like. It's a cubic curve. We knew it would be a cubic curve because our highest degree is a 3. Our next one is y is equal to, this one is linear. We should know it's linear because it's just an x plus 3. X plus 3. Okay, so here it is, and we're looking at where those are equal. So we're just looking at where they're going to intersect. So we have negative 3, 0. We have negative 1, 2. And we have 1, 4. And those are going to be your points of intersection and where they're equal to each other. So negative 3, negative 1, and 1. Negative 3, negative 1, and 1. Those are your x values, and if you plug in these x values to either one of these equations, the linear one will be a little easier. That's how you'll get the y values. Okay, so if we wanted to write them as points, the negative 3, 0, negative 1, 2, and 1, 4. Negative 3, 0, negative 1, 2, whoops, negative 1, 2, and 1, 4. Those are your points of intersection. Okay, so let's take a look here because we're now going to get to solving them algebraically. So if we take a look here, we're going to start off by multiplying these two out. So here we have a binomial times a trinomial. So whenever we have that, we're going to multiply the a, this term, to everything. And then we'll multiply b to everything. So multiplying in your a, we have a times a squared is an a cubed. We know that when we're multiplying and we have the same base, we keep the base and we add the exponents. 2 plus 1 is a 3. Minus, we have negative ab times a is an a squared b, and then plus b cubed. Oh, sorry. Oops. Oop. That was a squared b, and then plus ab squared. Okay, now we will do the b. So multiplying this in, we have plus, and then we're multiplying b times a squared. I'm going to put the a squared first because that's how it is first here. So I have an a squared b, and because of the commutative property, you can do that. Multiplying your b here, I have a negative ab squared, and then multiplying your b here, I have plus b cubed. So look what happens here. We have negative a squared b plus a squared b. That's going to cancel out. We have an ab squared minus ab squared. That's going to cancel out. So we're left with an a cubed plus b cubed. And this is going to go both ways. So if we have two perfect cubes, then it's going to factor out to be what we just had right here. Okay? And then the same thing will go for this one. So we'll do this a similar way. We'll multiply a to everything here. So doing that, we have an a cubed plus a squared b plus ab squared. And then multiplying in your b to every term here. And this is a minus, so a minus. And then again, I have the a squared b. The a squared is first here, so I'm going to put this as a minus a squared b. Negative b times ab is going to be a minus ab squared. And then negative b times b squared is a minus b cubed. And looking at what cancels out here, a squared b minus a squared b, that will cancel. ab squared minus ab squared, that will cancel. And therefore we're left with an a cubed minus a b cubed. Okay, so that is going to get to looking at perfect cubes as well. So when we're looking at perfect cubes, we want to know what that's going to look like. So if we have perfect cubes is, for example, if I say 1 cubed, that's 1. Or 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed, which is 5 times 5 times 5, 125. 6 cubed is 6 times 6 times 6, which is 216. 7 cubed is 7 times 7 times 7, which is 343. 8 cubed is 8 times 8 times 8, and that's going to give us a 512, and so on. Okay, so these are perfect cubes. We'll start with those. Okay, oops. So let's also remember that we also have the difference of two cubes. The difference of two squares, or dots. We called that dots. Difference of two squares, dots. So this one we have a difference, and both of these are perfect squares, a squared minus b squared, and then we were able to factor this as a plus b and a minus b. Okay, so this one would be able to be factored as one is a plus, one is a minus, and we know that we call these conjugates. These are called conjugates. And conjugates are just when the middle sign is different. That's the only difference between the binomials. So then we take the square root of this first one, that's a 2x. And we take the square root of 9, that's a 3. And that's how this one is factored. So similarly, we're going to be doing now the sum and difference of cubes. So this was the difference of two squares. Now we have the difference of cubes. And we actually already did this when we multiplied that binomial times the trinomial. We proved that this is what we'd get, a cubed plus b cubed. So if this is a plus, then we'll just have a plus b, same sign as here. And then we'll have your a squared. This will be the opposite sign, minus ab plus b squared. And then similarly, if it's a cubed minus b cubed, this is a minus, this one is a plus. So let's try some. Okay, so we're just going to start out with factoring here. So with factoring, we should be able to notice that these are both perfect cubes. 8 is a perfect cube because 2 cubed is 8. So we're going to start off by factoring this, and we're just going to be using that we know that a cubed minus b cubed, we know what that is, we just found that, and we're going to use that formula. So this is going to be a minus b times a squared plus ab plus b squared. That's what it's factored out to be, and that's what we're going to be using to factor this. So we have x minus 2 now because 2 cubed is 8. So that's how we get the b. And then we'll have your a squared is just your x squared. This is going to be a plus. You multiply these two, so this will be a 2x plus, and then whatever this number is squared. So 2 squared is 4. And that's factored. Okay, moving on. This one here. Similarly, we say the cube root of 8x cubed is a 2x. This is a minus. The cube root of 1 is a 1. Okay, and then we'll do it for, now we'll say 2x squared, using that here, is a 4x squared, plus we multiply these two out, 2x and 1 is a 2x, and then we do 1 squared is a 1, and that's factored out. Okay. Moving on here, now we're going to be looking at polynomial equations. So we're going to do this the same way that we just did the factoring, but now we have an equation. So we're going to write this out as, I'm going to say, what is the cube root of 27x cubed? So I'm going to write this out as using my sum of cubes here. So this is a plus b, and then this is a squared minus ab plus b squared. That's what that one is factored out to be. Okay, so doing that, we get the cube root of 27x cubed. That's going to be a 3x. And then plus the cube root of 1 is 1. Okay, and then we're going to be looking at same thing here. So using your 3x is now your a. So 3x squared, I'll just write that out here. So 3x, and then you're squaring that. And then you write this as minus 3x times 1, and then plus your 1 squared, which is 1. And that's all equal to 0. So just simplifying this a little bit, we have a 3x plus 1, and then we have a 9x squared minus 3x plus 1. Okay, so now we can just set each one of these equal to 0 and then solve that. So we have a 3x plus 1 equals 0. 3x equals negative 1, or x is negative 1/3. So here's one x-intercept. We just found an x-intercept of this cubic curve. X equals negative 1/3. Now we have this quadratic. So this value right here, this cube, this is telling you how many answers you're going to get. You're going to get 3 answers for a cubic. So now here, you're going to set this equal to 0 and you're going to solve. So you're going to use the quadratic formula for this because we can't factor this. So use a quadratic formula here, going x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so plugging in, we get x is equal to a negative 3 is 3 plus or minus the square root of, I have a negative 3 squared is 9 minus 4 times 9 times 1. Okay. And then we go 2 times a, or 2 times 9 is 18. Simplifying this here, we have 3 plus and minus the square root of, we do 9 minus 4 times 9 is 36. So minus 36 all over 18. 9 minus 36 is a negative 27 all over 18. And then we can break that up. So breaking up the square root of negative 27, we know that's going to have an imaginary number in it. So I'm going to break this up as a negative 9 times 3. So the square root of negative 9 is 3i square root of 3. So replacing that here, so I have 3 plus or minus 3i square root of 3 all over 18. And then I can take a 3 out of everything. So this will be 1 plus or minus I square root of 3 all over 6. Okay, so these are 2 answers because it's plus and minus. And here's our other answer. Okay, let's get to factoring by using a quadratic form. So for this one here, we have x to the 4th. And x to the 4th minus 2x squared minus 8. So what we're going to do for this is we're going to actually write it in a form that we are used to. So I'm going to write this in a form that's going to look like a quadratic expression. So I'm going to write this as something squared minus something linear, and then our constant. So in here, I'm going to put in whatever it will be equal to. So this is going to be an x squared, because x squared squared is x to the fourth. And then I'm going to put an x squared here because the x squared to the first is just x squared. And then what we're going to say is we're going to let a equal x squared. Okay, so now what we're going to do is we're going to replace your x squared with a. So I'm going to have this as an a for my x squared, and then I'm going to replace everything else. So this is going to be an a squared minus 2a minus 8. Okay, so that's just rewriting it and replacing your x squared with a. So now we're going to just factor a squared minus 2a minus 8 like we would for a regular quadratic. So I'm going to say what multiplies to negative 8 and adds up to negative 2. So that's going to be a minus 4 and a plus 2. Okay, now what we're going to do is you're going to substitute back to the original variable. So our original variable here was x squared. So instead of a, I'm going to put x squared in. So now I have x squared minus 4 and x squared plus 2. And that is now factored. Okay, so let's try one more of those, and then we can do one where it's an equation. So if we look at this one here, I'm going to do it the same way, where I'm going to write it as something squared, something linear, and then my constant. So in here, I'm going to write this as an x squared, and then again, I'm going to let a equal x squared. So I'm going to substitute my a in for x squared here now. So I have a squared plus 7a plus 6. And then I'm going to factor this. I'm going to say what multiplies to 6 and adds up to 7. And that's going to be a plus 6 and a plus 1. And now I'll substitute my x squared back in for a. So x squared plus 6 and x squared plus 1. All right. So for this one here, the first thing you'll have to do is subtract your 12 over. So you have x to the fourth minus x squared minus 12. And then that's equal to 0. So then for this one, again, we do it the same way. Something squared, something linear, minus 12 equals 0. So for this, I put in an x squared. And again, I let a equal x squared. So replacing your x squared, I get a squared minus a minus 12. And then I factor it. So I say what multiplies to negative 12 and adds up to negative 1. That's going to give me an a minus 4 and an a plus 3, because negative 4 times 3 is negative 12. And negative 4 plus 3 is a negative 1. Now, before I solve this, I'm going to plug x squared back in. So I have an x squared minus 4. I have an x squared plus 3. Now I will make my t-chart and solve. So this is going to give me x squared equals 4. Taking the square root of that, I get x equals plus or minus 2. So that's 2 answers. And this one is going to be x squared equals a negative 3. Taking the square root of that, I get x equals plus and minus. I have to take the negative out. So plus or minus I square root of 3. So if you notice here, we got 4 answers. We knew we were going to get 4 answers because that was the highest degree. So I have 1, 2 answers here, 1, 2 answers here, of a total of 4. So that's how we would solve it using substitution and making it into a quadratic. And that's all for today. Thanks for listening.